Okay.
All right, so this is a panel. This is a 375 kilowatt panel. This would be for a medium-sized factory with a fair amount of motors. Again, like we had with the little demo unit, you've got a main isolator feeding a number of fuse holders with fuses that are sized to the size of the steps. Here you have your contactors. Behind here are all the capacitors. In this instance, these are single-phase capacitors that are connected in delta. It is possible to have single-phase capacitors or three-phase capacitors. So as I explained to you, it's a very simple system. This is the brain here. Again, that's a different make of controller. This controller gets current and voltage feedback to determine the power factor. It has been programmed and been told that K1, contactor 1, has got so many kilowatts, contactor 2 has got so many kilowatts, so this whole 375 kilowatt is broken up in 6 blocks. And we've told the controller what the size of these blocks are. So basically, yeah, the brain energizes the capacitors so that it energizes the contactors so that the capacitors can be energized and do their job. For the bigger units, obviously you need ventilation. Ventilation is one of the key killers of power factor correction equipment. Capacitors absolutely hate elevated temperatures. So anything over 55 degrees, you are affecting the life expectancy of the capacitors. So ventilation is key. What is also very key, and people don't take care of it, but if you have fans, you also need an air intake. And what you get is that this will get dirty, and it doesn't get washed or replaced. And this is often what's happening, is that the filter is so blocked that the system cannot work. And the panel will then shut down on over temperature, and you will lose the savings. It's really stupid. You can't get this done by unskilled labor. It's as easy as this. You open up the grill, you remove the filter, and you either replace it or wash it. So it's one of the most frustrating things when we do services. The customer, we've explained and informed the customers what to do, and the only maintenance really is to replace these filters because there's no moving parts. All right, you're not expected to open up the contactors. They are designed to do their job. There's no need like in the old days where you had to open up contactors and clean the contact tips. It's not necessary. And then I need to point you to another thing here. You see the little block on top of the contactor. That's what we call a snubber circuit. So what this does is that I told you that capacitors are extremely aggressive to switch. So what happens if the brain now energizes the coil for this contactor and the contactor starts moving, it will initially start closing the auxiliary contacts that are mounted on top of the contactor. So what that does is that this is a resistive wire with a couple of turns. So that's an LR circuit. The R being the resistive wire, and then the coils here are the L portion of your LR circuit. So what happens? Just imagine this starts traveling and these auxiliary contacts close first. The main contacts have not closed yet. So what happens is the current will start flowing through this little wire, through this auxiliary contact, through this wire and this coil, and off to the capacitors. So what the result of that is that you start already having some sort of a controlled current flowing. Now, the contactor keeps traveling, and now the main contacts also close. Now you have the auxiliary contacts and the main contacts closed. And when it's fully traveled in, the auxiliary contacts open up again. Because you can't, this is not designed to keep, the current can't keep flowing there because it's a resistive wire. It will get stinking hot and burn. So that's the purpose of this device. Reversely, if the controller now says, no, you need to switch off, the contactor will start traveling backwards. It will close these contacts again. Now you've got your snubber circuit in parallel with the main contacts. Then the main contacts will open, and then the auxiliary contacts will open again. So this is all done during the travel time of the contactor while being energized or de-energized. So it is an extremely critical component for the life. Without it, these contactors will not survive. So these are normally motor switching contactors. But by adding this device and these wires, you actually make them capacitor switching. And we often see in the field when people that are not fully familiar with power factor correction, they will install a normal motor switching contactor. And in no time, these main contacts will fuse, which is a safety now issue, because the main contactors are fused, the controller has no more control over this. It will always be on. So it's an issue. So snubber circuits, they come in all sorts of shapes. Let me show you a different. So that's a different make, but they all have that block on top. See, similar thing, where this is a resistive wire, and these are the coils. They encapsulate it. This contact is much more expensive than the others. We prefer these, but they have a price, they have an implication on the price, and some customers are quite price sensitive, so then we use a different make. So yeah, that's basically it. This block is absolutely critical, and these little black devices that actually contain a coil, they're key. Okay, we can put that away a bit later.
Thank you very much.
So